Adding and subtracting with scientific notation. Essential question, how to add and subtract numbers in scientific notation. So a scientific notation form, we have an example right here, 4.35 times 10 to the power of 7. So when a number is in scientific notation, it is composed of a coefficient and a power of 10. And the coefficient will have one digit in the ones, place value that is a digit from 1 to 9. So how do you add and subtract with scientific notation? So step 1, to add or subtract, you need to ensure that the power of 10 has the same exponent. If the exponents are not the same, you need to make the exponents the same, and you can use LARS, which stands for left, add, right, subtract, which means that if you add to the exponent, the decimal moves to the left the same number of spaces. If you subtract from the exponent, the decimal moves right the same number of spaces. So let's try to apply that so you can see an example of it. So if we look at the first one here, the exponents are the same. So you don't need to use LARS or do anything to it. 3.1 times 10 to the power of 5 and plus 6.2 times 10 to the power of 5. You could go directly to step 2. But let's look at what we need to do if the exponents are different. So here we have 10 to the power of 5 and 10 to the power of 4. So we're going to turn this exponent of 4 to a 5. So we're going to add 1. So if we use LARS, it says if you add decimal point to the left. So the decimal point here is 8.3. We're going to move it one space to the left. So I'm going to rewrite this is equal to 9.4 times 10 to the power of 5 plus 0.83 times 10 to the power of 5. So now we're going to go to step 2. So step 2, you will add or subtract the coefficients and keep the same power of 10. So because in example 1, the powers were the same, we're just going to add the coefficients together. Add because there's an addition in between. So it's 3.1 plus 6.2, and then the power stays the same, which is 3.1 plus 6.2 is 9. 10 to the power of 5. Now let's look at example 2. We made the exponents the same, 5 and 5. So now we're also going to add, because there's an addition, the two coefficients. So 9.4 plus 0.83 10.23 ensure that the final answer is in scientific notation form, where the coefficient is a number between 1 and 10. Use LARS if needed to write the number correctly. So if we look at the first example, the coefficient is 9.3. There's one digit, so that is in scientific notation. There's one digit right before the decimal point. If we look at example 2, we have 10.23. So we need to change this 10 to a 1, which means we need to move the decimal point one space to the left. So if we're going to go and look at LARS again, so we need to move one space to the left, which means we need to add 1 to the exponent. So we're going to add 1 to the 5, which will equal 6. So if I rewrite this, it will be 1.023 times 10 to the power of 6. And for example 1, we don't need to write anything here. as the number is in scientific notation. 1a. So first thing we'll take a look at is the exponent. So the exponents are the same. So we're just going to subtract the coefficients, which is equal to 6.5 minus 4.2 times 10 to the power of 8, which is equal to 2.3 times 10 to the power of 8. Let's look at b. The exponent for the base power of 10 is 7, and the other power is 5. So we're going to change this power of 5 to a power of 7 so that the powers are the same, the exponents. So I'm going to add 2 to the exponent. So if we use, again, the Lars system, if you add 2, we're going to move the decimal point by 2 spaces to the left. So that's 1, 2, which will be 0.023. So I'm going to rewrite the question. 5.4 times 10 to the power of 7 minus 0.023 times 10 to the power of 7. So now I'll subtract the coefficients. 5.4 minus 0.023 times 10 to the power of 7, which is equal to 5.377 times 10 to the power of. We have powers of 10. One is -4, one is -3. So I'm going to turn the -4 into a -3, which means I need to add 1. So -4 plus 1 is equal to -3. So if we're going to add 1, we're going to move the decimal to the left by the same number of spaces, which is 1. I'm going to rewrite the question. 87 times 10 to the power of -3 plus 8.8 times 10 to the power of -3, which is equal to 0.87 plus 8.8 times 10 to the power of -3. It is equal to 9.67 times 10 to the power of -3.